Hello students, welcome to IMS GATE Academy. Welcome to the foundation course on geotechnical engineering. My dear students, if you can follow this foundation course, the agenda of this foundation course is to make the subject geotechnical very clear with the formulas and the concepts. So we have discussed in the previous sessions actually what is the properties of soil topics. We have studied about different topics like how do you represent a soil, what are the different properties like void ratio, porosity, air content, degree of saturation, and also we have derived some of the relations using these formulas. And we also have studied about the water content, and we also have studied about the borrow pit and fill problems. So in this session, I would like to cover the problems related to the properties of soil, and this session will definitely help you to solve the problems on properties of soil with ease. Okay, again, welcome to IMS GATE Academy students. Now here is the first and the foremost question. The true and apparent specific gravity of a fully saturated soil are 2.7 and 2 respectively. Calculate the void ratio of the soil. So whenever they have given any gate question, first try to understand the input data. There are two terms given in the question, my dear students. One is the true specific gravity and other one is the apparent specific gravity. So remember students, the true specific gravity will never change, and the apparent specific gravity depends upon the state of the soil. When you see the question here, the soil is in fully saturated state. So here the apparent specific gravity formula will vary with respect to the state of the soil. And he has asked the void ratio of the soil. So let us understand this problem in a simple way. So see students here, when I see the solution here, what is the given data we have? The given data here is the specific gravity. When you see the specific gravity is given as how much? It is given as 2.70. The specific gravity value is given as 2.70. Similarly, if we consider the mass specific gravity, so what is this G? If you see in the problem, it is called as true specific gravity. And the mass specific gravity is in which state? It is in saturated state for your information students. So here mass specific gravity of saturated state is given by the formula gamma sat upon gamma W. It is given by the formula gamma sat upon gamma W. See students, here it can be gamma D by gamma W, or it can be gamma upon gamma W, or gamma sat by gamma W. Now here you can ask me why I have chosen gamma sat by gamma W. Because here the question in the question, he has clearly mentioned that it is fully saturated soil sample. When you say it is a fully saturated sample, we have the formula gamma sat upon gamma W. Now here I would like to tell you, my dear students, you know gamma sat is equal to written as gamma W into G plus E upon 1 plus E. So this is the formula with respect to the specific gravity, void ratio and unit weight of water. So this, using this formula, this problem can be solved very easily. So let us see students here. You know gamma sat is equal to what, my dear students? Gamma sat is equal to gamma W into G plus E upon 1 plus E. Or this can be written as gamma sat by gamma W can be written as what, my dear students? It can be written as G plus E upon 1 plus E. So if you see here, what is the value of gamma sat by gamma W? That is nothing but the mass specific gravity. The mass specific gravity value is given as 2. And you know the true specific gravity is given as 2.7 plus E upon 1 plus E. Now if you solve this equation, you will get the value as 2 plus 2E is equal to 2.7 plus E. So you can write here, see, 2.7 plus E. So E can be written as 0.7. So they are asked in the solution, what is the void ratio of the soil sample? The void ratio of the soil sample is 0.7. Please follow this formula, students. Gamma sat is equal to what? Gamma sat is equal to gamma W into G plus E upon 1 plus E. Using this formula, you can write the void ratio as 0.7. This simple formula and the state of the soil will help you to solve this problem. I hope you are clear. Whenever this question is asked, remember you have to understand the mass specific gravity is given in saturated state or dry state or bulk state. Okay. Next, see students, we have the next question here. The second question what we are having is a sample of dry soil. Very good evening, sir. Atul, sir. A sample of dry soil. When they tell you it is a dry soil, so the state of the soil is how? It is in dry condition. A sample of dry soil weighs how much, student? It weighs 120 grams and its volume is 80 ml. If the specific gravity is 2.8, what is the void ratio of the soil? So let us understand what is the given data here, my dear students. So what is the given data here is, they have given the dry density, they have given the, they are asking the void ratio, they have given the specific gravity, weight of dry soil, and also they have given the volume. See students, this is the given data in the problem. So the condition of the soil is dry. So here when I see the dry density is given by the formula gamma W into G upon 1 plus E. This is the relation with respect to dry density. Now my dear students, how do you calculate dry density? Thank you, Prajna sir. So how do you explain the dry density? The dry density is given by the formula, weight of soil upon total volume. Weight of soil upon total volume. Here I will tell you very basic, student. Here they have given the volume in what units? 80 ml. See student, the intention of this problem is also to specify you the units. Here the volume is how much? It is 80 mm. Remember my dear students, as per the unit conversion, you know 1 liter is equal to 1000 ml, or 1 liter can be also written as 1000 centimeter cube. Or my dear students, you can write 1 meter cube is equal to 1000 liters. What made me to explain these problems is, you should know this basic conversion to solve the problem. So 1 liter can be taken as 1000 ml or 1000 centimeter cube, or 1 meter cube is equal to 1000 centimeter cube, 1000 liters, sorry. So here how do we solve this problem? So here weight of the soil is given as in the problem, clearly it is 120 grams. Now my dear students, here they have given the volume as how much? It is 80 ml. So ml units can be same as the cc, centimeter cube. So I will write these units as 80 centimeter cube. Why I have taken in centimeter cube, I will explain you. Don't worry about that, student. Now here the dry unit weight is given by the formula weight of soil upon total volume. So what is the weight of soil, my dear students? Weight of soil is nothing but 120 upon total volume is how much? It is nothing but 80, and this value is taken as 1.5 gram per centimeter cube. Some people will show it as GCC, or that you can write it as 1.5 gram per centimeter cube. Why I have taken gram per centimeter cube is, remember my dear students, the unit weight of water is 1 gram per centimeter cube, or it can be taken as 1 ton per meter cube, or it can be taken as 9.81 kilonewton per meter cube. See students, here they have given the units gram and ml, but if you see the gamma W units, we know the units in gram per centimeter cube or ton per meter cube. Why to convert? That is the reason I have converted ml into centimeter cube. Now we know the relation, that is gamma D is equal to what, my dear students? It is taken as gamma W into G upon 1 plus E. So here you know gamma D is 1.5 gram per cc and gamma W is 1. And what is the value of G given in the problem? It was given as 2.8. So the specific gravity, here you can ask me, my dear students, is it a true specific gravity or mass specific gravity? By default, if they have not mentioned anything, then it is a true specific gravity. So it can be taken as 2.8, which is given in the problem, upon 1 plus E. If you solve this, 1 plus E can be taken as 2.8 divided by 1.5. That will be equal to 1.86. That will be equal to how much, my dear students? 1.86. On solving, E can be taken as 1.86 minus 1. So this will be equal to 0.86. Any queries in this calculation of void ratio, my dear students? So here the void ratio, how do you calculate is, and I told you when I am explaining the dry density also, remember, my dear students, here when I apply the dry density formula, the important point I would like to tell you is, if you see in dry density, gamma W is a constant value and G is a constant value. Only the unknown is void ratio. See, in a mathematical equation, there is only one known. One unknown means one equation is sufficient. If suppose in this equation there are two unknowns, means you should develop another equation also. So this is the famous relation which will help you to understand the void ratio of the soil. So my dear students, again I want to tell you the important thing in GATE point of view, whenever you have time, first read the question carefully, write the given data. That will help 20% to solve the problem easily. Now coming to the third problem, it is an interesting problem related to the water content. So what actually is water content, my dear students? So water content is defined as the weight of water to the weight of solids. So let us see this question. The question here is, the weight of a container is 40 grams. The weight of a container is 40 grams and the weight of the container and wet soil is 100 grams. This you have to write it very carefully. The weight of the container is 40 gram, weight of the container and the wet sample is 100 grams. On woven drying for 24 hours, if you are drying for, on woven drying for 24 hours, the weight of the container with dry soil is found to be how much? With the dry soil, it is found to be 80 grams. So what is the water content of the soil? Very good question, students. So here, if you know the woven drying method, this problem is very easy. So I will tell you in a single line statement and we will discuss in detail also. So here, my dear students, when I talk about the water content, what do you mean by water content? Water content is defined as the ratio of weight of water to the weight of solids. So first of all, you should understand what is water content is. It is defined as the ratio of weight of water to the weight of solids. Now, how do you calculate this? See students, here I would like to tell you, the weight of the container is given clearly in the problem. The weight of container is given clearly in the problem. It is 40 grams. Weight of container is 40 grams. So here when I talk about weight of container plus wet sample, weight of container plus weight of wet sample is given as 100 grams. Now you, my dear students, you know already the weight of container is 40 grams. So if you substitute here weight of wet sample can be calculated as 100 grams. You can write it as 100 grams minus 40 grams. This will be equal to 60 grams. How much it is? So the weight of the wet sample is 60 grams. Now imagine students, this wet sample is placed in a oven. This wet sample is placed in a oven. After 24 hours, you will get the weight of dry soil, right? Because this 60 grams is placed in the oven, and after removing from the oven, because whatever the water in the soil, that will be evaporated, or you can say that water is removed. So now on heating, that water will be removed. So whatever the weight after oven drying, that will be the dry weight. So here they have given after oven drying. After oven drying means you have to think, it is simple that after doing oven drying, the weight will be dry. So here clearly students, the weight of dry sample, the weight of dry sample is how much? The weight of the dry sample given in the question is 40 grams. So students, here I have just calculated what? I have calculated the weight of wet sample only. So you know here what is water content here, students. So here you know what is water content. Water content is nothing but weight of water upon weight of solids. Remember students, weight of dry soil or weight of solids will be same. That is equal to how much given in the problem? It is 40 grams. And you know weight of wet sample is how much? Weight of wet sample is 60 grams. So how do you calculate the weight of water? Sir, this is dry weight and this is the wet weight. If you remove from the wet weight the dry weight, definitely you will get the weight of water. So weight of water is calculated as weight of wet sample minus dry weight. That will be equal to 60 minus 40 grams. That will be equal to 20 grams, my dear students. So how do you calculate water content? You know the value of the weight of water, that is 20 grams, and you know the weight of solids, that is 40 grams. So here what is water content is, you can calculate as 20 by 40, that will be taken as 0.5 value. My dear students, if they ask you the value of water content in percentile, you have to just multiply this value with 100. Please multiply this value, then you will get a value of 50 percentile. So when you know the concept of oven drying method, this problem is very easy. So if you want to solve this problem in one step, you can write here weight of dry soil is 40 and weight of wet plus container is 100 and weight of water is how much? Weight of water is 100 minus container is 40. So this will be equal to 60 grams. And one more thing students, here they might not, if they have not given weight of dry soil is 40 grams, they might have given in the problem like this. Weight of dry soil plus weight of container is 80 grams. Actually, this is what they have given in the problem. I have written directly. See here, weight of dry soil plus WC means weight of container, you can write. So here weight of dry soil means total weight is 80 minus container weight is 40 grams. So dry weight is 40 grams. Okay, students, if you are confused, they have given weight of container plus weight of dry soil is 80 grams. So if you remove the container weight, definitely you will get the dry weight. I hope this solution is clear for you. Now, see students, this is a beautiful problem. The problem here is a soil has a bulk density. So what is bulk density? Gamma value is given. A soil has a bulk density of 1.80 gram per cc at a water content of 5 percentile. A soil is having a water content of 5 percentile with a bulk density of 1.8. If the void ratio remains constant, then the bulk density for a water content of 10% will be. This is a beautiful question, students. It is very simple but a beautiful question. So how do you solve this question? So initially if you see here, the bulk unit weight, if you see here, the bulk unit weight is how much, students? It is 1.80 gram per cc. Okay. And we have a water content is how much, students? You have a water content of 5 percentile. Okay. Here he has used in the problem that void ratio remains constant. See students, this is a very important thing because it has a significance. So as you know, gamma, that is bulk unit weight, can be written as gamma D into 1 plus water content. In the previous sessions, I have derived the formula, how this formula has came. Gamma is equal to what, my dear students? What is gamma? Gamma is nothing but the bulk unit weight. It is given as gamma D into 1 plus water content. Now here, my dear students, if you observe, what is gamma D? Gamma D is gamma W into G upon 1 plus E. This is the formula for dry density. Sorry students. If you see the equation, as I told you, unit weight of water is constant, specific gravity is constant, and he has told in the problem that void ratio is also constant. When all the three terms are constant, gamma D will be also constant. This has very important meaning. If void ratio remains constant, then dry density will be also constant. So here from the mathematical relation, you can clearly say that gamma is proportional to 1 plus water content. How this formula you have to understand. You cannot write this statement if void ratio is not constant, my dear students. So from this relation, what I would like to tell you here is gamma 1 upon gamma 2 can be written as 1 plus water content 1 upon 1 plus water content 2. Agree, my dear students? Here you have to understand that when the void ratio is constant, then only we can write this relation. So here he has given clearly gamma is how much? Gamma is 1.8 and gamma 2 is, you don't know, you have to find out this value. Here at 1.8, what is the water content, student? The water content is 5%, and I have seen students, even as a teacher, sometimes we will write it as 0.5. These are the small mistakes you have to keep in mind. 5% is not 0.5. You can write 5% as 5 by 100. That will be equal to 0.05. So take your time in calculation, students. So here upon 1 plus water content into, what is the water content? He has asked a value of 10 percentile. If you see the problem, he has asked the bulk density at a water content of 10 percentile. So here if I solve this problem, gamma 2 will be taken as what? 1.8 into 1.1 upon 1.05. Can anyone tell me what is this value, students? So it is 1.8 into 1.1. It is 1.98 divided by 1.05. So what is the value? Can anyone tell me? Is it clear, students? So it will be roughly around 1.866. Okay, what will be the graph? Or 1.88. If you can see the calculator here, students. One second. If I see here the calculator, 1.98 divided by 1.05. It is 1.88, students. Make a correction here. It is 1.88. So what will be the units? Units is given in gram per cc. So here also it can be written as 1.88 gram per cc. Agree, students? So the bulk density is given as 1.88 gram per cc. So here we have understand that two concepts. When void ratio sorry, student. When void ratio remains constant, you should understand that dry density is also constant. How this relation can be used is, when void ratio remains constant only, this relation can be used. I hope you are clear. Now let us move on to the next problem. My dear students, take your time to read this question. what is the question here we have is, if a soil sample of weight is 0.18 kg. So here what is the sample weight is 0.18 kg. Having a volume of 10 power minus 4 meter cube. So in this today's session, the topic is related to the problems and properties of soil, student. The volume is 10 power minus 4 and he has given a dry unit weight of 1600 kg per meter cube is mixed with 0.02 kgs of water. What is the final water content of the soil? What is the final water content of the soil? My dear students, see here, when I talk about the solution here, when I talk about this solution, here what I would like to add here is very important thing, student. A sample is given with a weight. A sample is having a weight of how much? It is having a weight of 0.18 kg. Agree, students? And it has a volume of how much? Volume is equal to 10 power minus 4 meter cube. So students, when I talk about the bulk density, how do you calculate the bulk density? Bulk density is given by the formula weight upon volume. So gamma is calculated upon weight upon volume. So here the weight is 0.18 divided by 10 power minus 4 divided by 10 power minus 4. This will be taken as 800 kg per meter cube. This will be taken as 800 kg per meter cube. If required, actually this is not required, but if you require this, I am calculating. Now, here another important thing. Dry density is given as how much, students? Dry density is given in the problem. It is given as 1600 kg per meter cube. Dry density is given as 1600 kg per meter cube. So how do you calculate dry density? Dry density is given by the formula weight of solids upon total volume. Dry density is given by the formula weight of solids upon total volume. What is the weight of solids here? It is, we don't know, but you know the total volume is 10 power minus 4 meter cube is equal to, what is the gamma D value, students? It is 1600 kg per meter cube. So it is evident from this relation what is the weight of solids. From this relation, calculate what is the weight of solids. So the weight of solids from this relation, you can write it as 0.16 kg. So what is the weight of solids, students? The weight of the solids from this relation is 0.16 kg. I hope you are clear. Now, he has given total weight is 0.18 kg. Now, from this relation, what is the weight of water? How do you calculate the weight of water is? Weight of water can be taken as total weight minus dry weight or weight of solids. That is equal to 0.18 kg minus 0.16 kg. That is weight of solids, or you can write weight of dry soil. Okay, anything is fine. So the weight of water will be equal to how much, students? It will be equal to 0.02 kgs of water. So here when I talk about the now see, students, the weight of water, whatever you have calculated is how much? The weight of water is 0.02 kgs. Now this weight, remember students, this weight is mixed with 0.02 kgs. They have added another 0.02 kgs of water to this. Okay. So in this case, what you will get the total weight of water is, the total weight of water will be equal to 0.02 plus 0.02 kgs of water. So the total weight of water is 0.04 kgs of water. Okay. Now what will be the weight of solids? The weight of solids is given clearly 0.16 kg. So he has asked in the problem, what is the water content? So how do you define the water content is? Water content is given as weight of water upon weight of solids, that will be equal to 0.04 kgs of water upon weight of solids is 0.16. If this will be equal to 0.25, or if you want the answer in percentile, just multiply with 100, you will get the answer in percentile. So I hope you are clear with this. Okay, student? Student, take a 20-second break. Hello students, welcome back. Now see, I hope you are clear with the previous problem. So let us see the next question here. The question here is, for a soil in a natural state, the void ratio is 1. Water content is 30 percentile. Degree of saturation, specific gravity is 2.5. Calculate the degree of saturation. It is quite simple, students. Please give a try. The problem is quite simple. They have given everything in the problem. For a soil natural state, the void ratio is 1, water content is 30 percentile, and specific gravity is 2.5. What is the degree of saturation? Please solve that problem. Okay, students, see. He has given in the problem the solution I am trying to say here. The solution here is, they are trying to ask what is the value of degree of saturation. So when I talk about the degree of saturation, here you know the void ratio is given by the formula water content to G upon SR. This is the relation for void ratio, water content, specific gravity and degree of saturation. Now how do you calculate the degree of saturation is? Degree of saturation is given by the formula water content to G upon void ratio. Here it was clearly given in the problem. What is the void ratio? The void ratio value is 1. And what is the specific gravity? It is given as 2.5. And what is the water content? It was given as 30 percentile. So just multiply with 30 percentile here. Or you can take 30 percentile. If you take the value, it will be 30 upon 100. This value will be equal to 0.3. So on solving this value, you will get degree of saturation is 0.75. If you want to express the solution in percentile, then it will be equal to 75 percentile. Then it will be equal to how much, students? It will be equal to 75%. You can ask me one important doubt. Sir, the question seems to be very simple. But this question was asked n number of times in IAS prelims as well as in GATE exam. So the relation between void ratio, water content, specific gravity and degree of saturation, you should be very clear, my dear students. So let us move on to the next question. Here comes a beautiful question for you students. The question is, imagine students, the question here is, a saturated clay has a water content of how much? The water content is given as 39.3 percentile and the bulk specific gravity of 1.84. Calculate the specific gravity of the soil. See, this question you can ask me, my dear students. So whether it is a specific gravity means whether it is mass specific gravity or whether it is a true specific gravity. Remember, my dear students, whenever you are solving the term specific gravity, by default it is nothing but the true specific gravity of the soil. And he has asked what is the void ratio of the soil. So let us solve this problem, my dear student. The solution is quite simple. Here he has given the water content. So what is the water content he has given in the problem? He has given the water content is 39.3 percentile. So this value is equal to 0.393. And he has given the bulk specific gravity of 1.84. So here if you see what will be the gamma, if you see what is bulk specific gravity is, it can be the mass specific gravity Gm is equal to gamma by gamma W is equal to how much it is? 1.84. So anyhow you know what is the units of gamma W. I told you it is nothing but 1 gram per cc, or you can write gamma is equal to 1.84 gram per centimeter cube. How do you know that it is 1.84 gram per centimeter cube? Because gamma W, that is nothing but the unit weight of water. Unit weight of water, gamma W is nothing but how much? It is equal to 1.84, gamma W is 1 gram per centimeter cube. Okay. So here we have calculated the bulk unit weight. Now see students, we know the bulk unit weight is given by the formula gamma is equal to gamma W into G plus E into SR upon 1 plus E. Okay. Now when you solve this problem students, you have to understand that here gamma by gamma W is equal to G plus E into SR upon 1 plus E. See students, okay, please observe this relation students. So here you know E into SR is given by the relation E into SR is water content into G. He has given clearly in the problem what is the value of water content. It is 39.3 percentile. So E into SR can be taken as 0.393 into G. But remember students, here what is the value of degree of saturation given in the problem? It was given it is a fully saturated or the term saturated. That itself means that the degree of saturation value is 1. So you can write here E value is 0.393 G. Yes or no, my dear student? So if you solve this problem, so if you can substitute here, what is the value of gamma upon gamma W? Clearly mentioned in the problem, the bulk specific gravity is 1.84. So this value is 1.84 and you have to know the value of G. And you know what is E into SR? The value of E is 0.393 G and the value of degree of saturation will be equal to 1. So what will be the value upon 1 plus 0.393 G. Okay students, on solving this, what is the value of G? Can anyone tell me? There is only one unknown, one equation. So here the unknown is specific gravity. If you solve this equation, 1.84 is equal to this equation, if you solve, you will get a value of G is equal to how much? The G value will be equal to around 2.74. What is the value of G? 2.74. So what is the important thing here is, you should not panic that they have not given gamma value. They have given the bulk specific gravity means they have given the value of gamma upon gamma W. So and they have also used the term saturated. Saturated means degree of saturation is equal to 1. And how to solve the void ratio? We know the void ratio is nothing but, you know the value of G, specific gravity is 2.74. So how do you calculate the void ratio is 0.393 into 2.74. This will be equal to 1.08. So here the void ratio is how much, student? The 0.393. The value of specific gravity is 2.74. You will get a value of void ratio is 1.08. So they have asked in the problem clearly, what is the value of void ratio? The value of void ratio is 1.08 and what is the value of specific gravity is 2.74. I just want to tell you how easily you can solve this problem is, if you know that gamma is equal to gamma W into G plus E into SR upon 1 plus E. If you know this relation, students, you can solve any problem. You can solve any problem if you know this relation. I hope you are clear with this problem. Now see, students, a soil has a porosity of how much? A soil has a porosity of 40 percentile. Specific gravity is how much, students? Specific gravity is 2.5. And the water content is how much here? Water content is 12%. Calculate the water content at fully saturation. The first question they have asked is, they have given the value of porosity, they have given the value of specific gravity, and they have given the water content value as 12%. The first and the fourth question is the water content at fully saturation. So let us solve this problem. So in the first question, what they have asked is, calculate the water content, calculate the water content at fully saturation. How do you calculate the water content at fully saturated? See, student, you know E is equal to how much here? E is equal to water content of G upon SR. He is asking what is the water content in fully saturated state. So in fully saturated state, the value of degree of saturation will be equal to 1. So he has given in the problem, the porosity value is 0.4. Now what is the relationship between porosity and void ratio? The relationship between porosity and void ratio is given by the formula N is equal to E upon 1 plus E. So here you can write E upon 1 plus E is equal to 0.4. On solving this, you will get E is equal to 0.4 plus 0.4 E, and E will be value. What is the value of E from this relation? E will be taken as 0.67. So now you have to calculate what is the water content in fully saturation. The water content for fully saturation from this relation, if you see, water content is given upon void ratio upon specific gravity. So what is the void ratio they have given? The void ratio is given as what we have calculated is 0.67. So the water content is, void ratio is 0.67 divided by 2.5. So what is this value? Can anyone tell me what is the value of 0.67 divided by 2.5? Anyone? Sir, see here, if you don't have the calci, I will let you know. It will be around 26.6%. So you can write here 0.67 divided by 2.5. So it is around 0.268. So what is the water content value here? It is 0.268. If they ask you in percentile, this value will be equal to 26.8 percentile. So students, when they ask you what is the water content for fully saturation is, water content is E upon G. See, when we have to use the formulas, that is the most important tricky part in properties of soil, student. Which formula when we have to use? That problem how you will overcome is, first try to write the given data. By looking into the given data, if you are aware of the formulas, then automatically you can write the relation. See students, I know that E is equal to water content to G upon S, sir. But did I know what is the value of E in the problem? No. How to find out the E with respect to the void ratio? So we know that, how to find out the void ratio with respect to the porosity. So we know that the relationship between porosity and void ratio is given by the formula N is equal to E upon 1 plus E. So when we know that porosity and void ratio relation, easily we could find out the void ratio. Once you know the void ratio, just plug in that values and you will be getting the water content. Okay. Now he has asked in the second problem. See student, this is the beautiful problem. The question here is, what is the weight of water? He has not asked the concept water content. Now the term comes weight of water. What is the weight of water required to be added? This is a very, very important term. See, already there will be some water, and how do you add that water for 100 meter cube of soil for fully saturation? Okay. Now see students, he is asking the weight of water is how much? So see students, weight of water to be added also you have to remember. He is asked in the problem, what is the weight of water to be added? So how do you solve this problem, students? So you know here what is water content? Water content is defined as the ratio of weight of water to the weight of solids. How do you define the water content? It is defined as the ratio of weight of water to the weight of solids. So from this relation, weight of water is calculated as water content into weight of solids. But he has used the term added. So you know already in the A problem, we have calculated whatever the water content in fully saturated state. The water content for fully saturated state, just now we have calculated that the water content value is equal to how much? It is equal to 26.6 percentile, or it is equal to 0.266. So here what will be the weight of water is water content into weight of solids. So here you can write, if they ask you the word weight of water to be added, this is important students. Weight of water to be added is given by the formula water content 1 minus water content 2 into weight of solids. How can you write weight of solids, students? If you know the volume, so weight of solids is calculated using the relation gamma D into volume. So you can also find out weight of solids by multiplying dry unit weight and the volume. So let us do weight of solids can be written as gamma D into volume. Gamma D into volume. So weight of water to be added is given by the relation water content 1 minus water content 2 into dry density into the volume. Are you clear, students? So let us see what is the initial water content. They have given the initial water content as how much? It has given as 12%, and the water content at fully saturated is 26.6 percentile or 0.266. Agree, student? So here weight of water to be added, weight of water to be added is given as water content 1 is how much, student? It is given as 0.266 minus water content 2 is 0.12, and the volume they have given. What is the weight of water to be added for 100 meter cube of soil? So for 100 meter cube of soil is volume is 100. So we have to find out what is gamma D. Gamma D is nothing but the dry density. Gamma D is nothing but the dry density. So how do you calculate dry density? Is gamma D is equal to gamma W into G upon 1 plus E. So if you see the first, what is the relation they have given? If you see here, they have given porosity as 40%, G is 2.5%. 2.5. So here gamma W is 1 gram per cc, G value is 2.5, and using the relation we have already calculated that what is the value of void ratio? 0.67. Because porosity is given as 40%, you know already we have done that N is equal to E upon 1 plus E. What is the value of E? It is 0.67. You got, because you know porosity is 0.4. So if you substitute here, it will be 0.67. And this value on substituting, you will get a value of 1.5 gram per cc. This is very important, student. Again, I'll tell you. Here the units of 100 is in meter cube. Here the units of 100 are in meter cube. So you can directly take this one units will be ton per meter cube. Again, if you take gram per centimeter cube, means when you are doing the cancellation, either this ton per meter cube should be converted into gram per cc. So that conversion is not required. So you can directly take it as 1.5 ton per meter cube. Here you can take weight of water to be added is 0.146, okay, into 100 into 1.5. So this weight of water to be added, or you can just plug in this value. Here you can write gamma D is 1.5. When you plug this value, you will get a value of weight of water to be added is how much? The weight of the water to be added is 21.9 tons. If you plug this value, you will get a value of 21.9 tons. Okay. So here, most of the students might do a mistake taking the water content directly 0.266. That is absolutely wrong. You should be patient enough to understand this problem, because he has used the word added. Whenever the term added is come, you have to find the difference in the water content. That is a very important thing. Now, the third question is, see student, the third question is, initially the volume is 100 meter cube. Initially the volume is 100 meter cube. Now the volume is increased by how much? The volume is increased by 5 percentile. Now, if the volume is increased by 5 percentile, what is the weight of the water required for fully saturation? That is the question, see student. If you see the third question, okay, third point here, what he has asked here is, 1 second student. So here if you see the question, what he has asked is, what is the water content which can fully saturate and increase the volume by 5%. This is very important, student. So here, the next point I would like to discuss here is, volume is increased by 5%. So you know volume 2 will be equal to 5% means it is increased. So you can write 1.05 into 100 meter cube. So volume in this case will be equal to 105 meter cube. I have discussed clearly how do you write the volume relation. Volume relation can be written as total volume of voids plus volume of solids. If you take here volume of voids common, okay, sorry. Here if I take the volume of solids common, you can write it as 1 plus Vv upon 1 Vs. I have discussed this relation in the previous sessions. So you can write here total volume is equal to Vs into 1 plus E. So from this relation, I would like to tell you one important thing, that the total volume is proportional to 1 plus E. You have to remember this also. So what I would like to tell you here is, V1 by V2, which I have derived already, V1 by V2 can be written as 1 plus E1 upon 1 plus E2. So what is the V1 here? What is the initial volume? Initial volume is taken as 100 meter cube. Initial volume is 100 and volume in the second case is 105 meter cube. This will be equal to, what is the initial void ratio? 0.67 upon 1 plus E2. So simply you can do this problem. See students, if I use the calculator here, if you can write here 1.05 into 1.67. If I do this, you will get 1.735. If you do this, you will get a value of E2 is equal to 0.7535. What is the value of void ratio? Here the void ratio is given as 0.7535. But he has asked in the problem, What is the water content? Now, what is the water content for fully saturation? Sorry, what is the water content if the volume is increased by, 5% in case of saturated state. In case of saturated state. So here what I would like to tell you is in case of saturated state. So what I would like to tell you here is whenever they use the term saturation, saturation means here the value will be equal to 1. So water content can be directly written as E upon G. So what is the value of E you have calculated is 0.7535. See students, upon G is 2.5. I have explained you already how easily we can do this. You know E is equal to water content into G upon SR. Here what is the value of degree of saturation? Degree of saturation is taken as 1. So here water content can be written as E upon G. So how do you write? Water content can be written as E upon G. So E is nothing but 0.75 divided by 2.5. So if you see the calculator here, it will be around 30% if I am not wrong. 0.7535 divided by 2.5. You will get around 30%. So this will be equal to 0.3014, or you can write 30.1 percentile. So see students, let us summarize this problem. In this problem, they have asked 3 parts. So previously, in way back in up to like 2003 or 2000, up to almost 2009-10, we used to have a linked up question. This is one of the previous gate question only. That is a linked up question. So here what they have given is, here if you see in the present gate exam, every part can be a 2 marks question, student. So almost 3 problems have been done in this single question. So what they have given is, they have given the porosity value, they have given the initial water content. The first question is water content at fully saturation. Based on the porosity, you have calculated the void ratio. After calculating the void ratio with the relation of E is equal to Wg upon SR, the water content at fully saturation is calculated. Okay, once you have done the water content at fully saturation, you have to find out the weight of water in case of fully saturation. So if you see, this is how we have done. How do you calculate the water content? Now, how do you calculate the weight of water to be added for fully saturation is, weight of water is taken as water content into weight of solids. As he has used the word added, you have taken the difference in water contents in fully saturated state and the natural state, because initially it will have some water content. When you find the difference in water, how much extra water can be added, that will be calculated, and weight of solids is calculated using gamma D into volume. And the last one they have asked you, in what is the water content if the volume is increased. So remember student, what is the famous thing what I have observed in this problem is, when the volume is increased, definitely there is a change in void ratio. So as the volume is increased, what is the change in the void ratio has been calculated. Once the void ratio has been calculated, just plug in that values in the relation E is equal to Wg by SR. As in the problem he has given fully saturated, you can take the value of degree of saturation as 1. So this has high chances on this concept. I never say this problem will come, but this concept will have a high advantage in GATE 24 paper, student. Now let us see the next problem here. It is also a straightaway problem if you have discussed all the problems what we have discussed until now. So the problem here is, a soil has a bulk density of how much? A soil has a bulk density of 2.05 gram per cc. A soil has a bulk density of 2.05 gram per cc and a water content of how much, students? And a water content of 18 percentile. So here G is 2.67. The first question is void ratio. So let us see how do you calculate the void ratio. So void ratio is given by the formula E is equal to water content to G upon SR. Okay. Here the water content is given as how much? The water content value is given as 18 percentile. So this value will be taken as 0.18 and the specific gravity is 2.67. Specific gravity is given as 2.67. So first of all, we should know what is the void ratio to use this relation. Okay. So to use this relation, whether we can use this relation or not. See, here you know the water content is 18%. Specific gravity is 2 point. But there are two unknowns. So this, I have done this intentionally, student. So this formula will not solve your purpose. So let us see. Bulk unit weight is given as gamma 2.05 gram per cc. Gamma is 2.05 gram per cc. So here students, when I solve this, dry density gamma D is equal to gamma upon 1 plus water content. So you can write here, what is the bulk density they have given? They have given the bulk density as 2.05. 2.05 upon water content is 1 plus 18 percentile, that is equal to 0.18. So here you can write, students, what you can write here is, so what is the value of dry density? You can write value of dry density is equal to 2.05 divided by 1.18. So this value will be around 1.737 gram per cc. 1.737 gram per centimeter cube. See students, why I have written gamma D is, there is only one unknown here. So here you know gamma D value is how much? Using the relation gamma D is equal to gamma upon 1 plus water content. Gamma is equal to how much we have done? 2.05 upon water content is how much? 18 percentile. So substitute 0.18. So you will get a value of how much, students? You will get a value of 1.737 gram per centimeter cube. So see students, when I write here gamma D is, you know gamma D is equal to gamma W into G plus 1 plus E. So what is the value of gamma D? It is 1.737 gram per centimeter cube. So in case of dry density, gamma W will be also 1 gram per cc. And what is the value of specific gravity they have given? The value of specific gravity is given as 2.67 divided by 1 plus E. Okay. If I see the calculator here, student. Okay. If I see here, again the same thing, 2.67 divided by 1.737. So here it will be, how much here it will be? 1.537. If you solve this, you will get a value of E is equal to 0.537. If you solve this, or this will be approximately equal to 0.54. So here if you see the first one, how do you calculate the void ratio? It is calculated as 0.54. Now see students, what is the unique thing here is, if you see this relation will not help you to solve the problem easily, because they have given bulk density. Again, if they have given bulk density means you have to go using this relation. See, this relation and using this relation. If you combine these two relations, G plus ESR upon 1 plus E. If you combine these two relations, you can solve again. But it is the easiest way to solve this problem. The next one, what he has asked, the degree of saturation. Now, in this case, you can do that. So, you know what is the problem, students? Void ratio is given by the formula water content to G upon SR. Void ratio is given as water content to G upon SR. What is the void ratio you have calculated? It is given as 0.54, which you have done. Now, what is the water content you have calculated here, students? The water content is also given. It is given as 18 percentile. So, 0.18. And the specific gravity is given as how much, student? It is given as 2.67 divided by degree of saturation. So, how do you calculate the degree of saturation is? It is given as 0.18 into 2.67 upon 0.54. So, here if I see this, you can write here 0.18 into 2.67 is divided by 0.54. So the degree of saturation will be 0.89. If they ask in percentile, it will be 89 percentile. So see students, here it will be equal to 89.5 percentile. If you take the value of void ratio as 0.537, you can solve this. Okay. I hope you are clear with this problem. So let us, students, I'll give you 30 seconds to read the question properly. A soil is to be excavated from a borrow pit. What is the question here they have given? A soil is to be excavated from a borrow pit which has a density of 1.75 gram per cc and a water content of 12 percentile. Specific gravity of the soil is 2.7. See students, when I am telling in the previous sessions, we have discussed how we can solve the problems related to the borrow pit and fill problems. So here he has given in the problem clearly the density is how much? 1.75 gram per cc and water content is 12 percentile and specific gravity is 2.7. The soil is to be compacted to that a water content of 18 percentile and 1.65 gram per cc for a 1000 meter cube of fill. For a 1000 meter cube of fill, estimate the quantity of soil to be excavated from the pit. Estimate the, so here he has given, there are two things here student. One is the borrow pit. So from here, this you will talk it as borrow pit. Okay. And here, this we will call it as fill. Okay. Now see students, if you see here, borrow pit is having a density of how much? Borrow pit is having a density of 1.75 gram per cc. And the water content is how much here it is? Water content is given as 12 percentile. Okay. And if you see for a 1000 meter cube of fill, okay, here the dry density is given directly. Here they have not given gamma, they have given gamma here. Here the dry density is given as 1.65 gram per cc and they have given C and a water content of 18 percentile in the fill and a water content of 18 percentile. So what he has asked in the first question is, what is the volume of the borrow pit? Estimate the quantity of soil in the borrow pit. So you know already students, I have told you already, for a given soil, what is happening? For a given soil, what's happening is, for a given soil, volume of solids is constant and weight of solids is also constant. For a given soil, you should remember students, volume of the soil and the weight of the soil is constant. You have to remember these things. So here what I would like to tell you is, you can write either gamma d1 by gamma d2, which I have told you already these relations, is equal to V2 by V1 is equal to 1 plus E2 upon 1 plus E1. This is the relation. Now see students, first of all, you know here dry density is how much here it is? 1.65. Now how do you calculate if the bulk density and water content is given? If the bulk density and water content is given, how do you calculate dry density? Dry density is equal to bulk density, that is gamma upon 1 plus water content. Gamma is given as 1.75 and the water content is how much it is? 12 percentile. So 1 plus 0.12, that will be equal to 1.56 gram per cc. So what is this value here is 1.56 gram per cc. So here what I would like to tell you is, gamma d1 by gamma d2 is equal to how much students? Gamma d1 by gamma d2 is equal to V2 by V1. So here gamma d1, if I take borrow pit, that is how much you got here? You got it as 1.56 and gamma d2, this is taken as how much? 1.65 given in the problem. What is the volume they have given? They have given the volume as 1000 meter cube of fill upon volume of V1. So what will be the volume of the borrow pit, or estimate the quantity of the borrow pit is V1 can be written as 1000 meter cube multiplied by 1.65 divided by 1.56. If you solve this equation, you will get a value of 1056 meter cube. You will get a value of how much? 1056 meter cube. Any doubts in this, students? So this simple relation, gamma D1 by gamma D2 is equal to what? V2 by V1. With that simple relation, you will calculate the V1 answer. Is it clear? Any doubts in this, students? Okay. Now we have calculated, the first one is estimate the quantity of soil to be excavated in meter cube. Estimate the quantity of soil is how much, sir? We got this answer as 1056. Again the same question he has asked. What is the amount of water to be added? This is very, very important, student. The same thing what we have done in the previous problem. So when they ask you weight of water to be added in tons is given by the formula gamma, you see here, student. One important relation also you can, sir, you know gamma D1 is equal to gamma D2 into V2. Okay, or you can write this as weight of solids also. This relation also you should be aware. Here what I would like to tell you is, you can write gamma D1 by V1 is nothing but what? Weight of solids, because water content is taken as weight of solids into water content 1 minus water content 2. Okay. So here what I can take is gamma D1 is how much, friend? In this second case it will be 1.75. I will take in ton per meter cube, because they have given volume in 1000. Volume is 1000 meter cube. And the first water content is taken as 18 percentile. So amount of water to be added is 0.18 minus 0.12. So here 1.65 into 1000 into 0.18 into 0.12. If you solve this, this will be 1650 into 0.06. That will be 96, 99. So this will be equal to 99 tons. Okay, so what is the extra amount of water to be added is 99 tons. So here the simple thing is weight of water is equal to water content into weight of solids. And how do you write weight of solids is, you can write the weight of solids as gamma D, dry density into volume. If you can solve this, you will get the weight of water. I hope you are clear with this solution. Now see, students, I would like to tell you. See, students, I would like to summarize the concepts what we have learned today. So what we have learned in the today's concept is, mostly we have calculated the void ratios using the formula what void ratio is equal to water content to G upon SR. So WC is the water content, G is the specific gravity, and D is the degree of saturation. And dry density, if you see, students, most of the problems, gamma D is equal to gamma W into 1 plus water content, or gamma W into G upon 1 plus C. As I am telling you in the previous sessions also, these formulas are very important. And gamma is equal to gamma W into G plus E upon 1 plus E into SR. In case of gamma sat, you will take gamma sat is equal to gamma W into G plus E upon 1 plus E. And remember, we have discussed borrow pit problems. You know, V2 by V1 is equal to, this is very important relation, students. Gamma D1 by gamma D2 is equal to 1 plus E2 upon 1 plus E1. Students, whatever we have discussed, like water content is equal to weight of water into weight of water by weight of solids. These relations in the today's problem, these are the relations which we have used mostly to solve the problem. Students, actually one important thing I would like to tell you, the foundation course is completely free. Whenever you have find time, Please go through these concepts to brush up your initial concepts. If you can have these concepts clear, definitely from geotechnical engineering, especially from properties of soil, you will get 2 marks easily, student. So if you are understanding the concepts clearly, please share this session to your friends. Students who have the real aspiration towards the gate, the agenda of this course is to help the students in this regard to achieve the better rank. So once you have gone through the videos, you have to clearly understand how the problem has been explained. Okay. And important note things what I would like to tell you here, students, about our institute. What IMS see, students, actually in gate 23 we have an extraordinary results with different single digit numbers in different departments. So we can say one important thing, students, we have a course called zero fee program. You can visit the website imsindia.com and go to the zero fee program. In that zero fee program, you have 100 plus hours of concept videos and 12 chapter tests, 6 subject tests and 6 past gate papers across the streams. So if you have time, please utilize this opportunity. At least this will also help you as a foundation course. And one important thing I would like to tell you, this is completely a free course. This is completely a free course. That is the reason I'm not doing any kind of marketing here. It is a completely free course. If it is really helpful for you, just try to log in my imsindia.com and definitely you will get the understanding. And what we do at IMS India, this is important, student. We can proudly say that IMS is the only center which is offering offline center and as well as online gate coaching. Offline center we are at Jayanagar, that is at Southern Circle, and also we are at Vijayawada near to the Ben Circle. And Vijayawada, we are the only offline center who are providing the gate coaching. So what are the course features of IMS is, we have 800 hours plus live sessions and 130 plus online tests. In this online test, we have subject test, multiple tests, all India mock tests, chapter wise tests. On all these tests, around 3000 to 4000 questions will be covered. We have 20 to 30 exercise books and theory books, and we have topic wise, like in recently editions we have seen multiple select questions, multiple NAT questions. All these also have been added in the practice. And we have one-to-one mentorship, which is a very important parameter in the point of student, because where we have one-to-one mentorship, where the student weakness can be converted into the strength. And we have already the recorded sessions, and these recorded sessions with high HD quality, and you can go through that recorded. We have revision classes, and we also have SLP program, that is self-learning program also. Now see, student, we have the center address here. You can go through the address clearly. Here what we have provided is admission. So here what you can contact our IMS GATE Academy at Vijayawada Circle near to the Ben Circle. Okay, that's fine. So again and again we are starting the batches for gate 24 as well as 25. And thank you. If you have any queries, you can visit IMS India GATE, imsindia.com, IMS India GATE, in the domain, gate domain, you will see all these things. Okay, I hope these sessions will be helpful. And students, not only for civil engineering, we have been in our YouTube channel for all the branches. Please like the videos. If these videos are really helping you, definitely share these videos. The basic agenda of this sharing the videos, why we are asking here is, when more and more students comes, that will help us to we will be showing more enthusiasm towards the subject. Okay, thank you.